So in this question here, we've got a situation where a tow truck is trying to pull a van up a hill. The tow truck is 2,000 kilos and the van is 1,200 kilos. And the tow truck is pulling at a force of 2,320 newtons with a resistance force of 800 newtons. And the van has a resistance force of 240 newtons. Now, the hill that they're pulling on is given as an angle theta, and all we know is that sine of theta equals 1/20. Now, what we want to know is, does the tow truck have enough power to pull the van up the hill, and calculate the tension and acceleration. So the tension is the tension in the ropes, and the acceleration, is it going up or does it actually go down because it's not producing enough power? So let's work that out. So let's have a look at the motion up the hill or down the hill, whichever the case may be. Now, if it's going to be down the hill, the acceleration will be negative. If it's uphill, the acceleration will be positive. So let's resolve our forces. So going up our hill. So let's do everything together and see what we get. So the forces going up the hill are 2,320. So we've got 2320 newtons going up the hill. And what else have we got going up the hill? Well, we've got tension going up and down, so they will cancel each other out. So I'm going to miss those out. But we've also got these 800 and this 240 going against the direction of travel or direction of proposed travel. So minus 800 newtons, minus 240 newtons. Then we've also got to contend with the actual hill and the gradient of the hill. There'll be forces acting upon these vehicles with regards to sine of theta. So if I just draw a normal line going in a downward direction here, and what would happen is the force would be acting vertically downwards. And if we make a right angled triangle here, this angle here would be our theta, and then this here would be our opposite side, which would be parallel to the road that the vehicles are driving on. So this here, this magnitude here is what we need. So that would be given, because it's opposite, that's where our sine of theta will come in. So it's 2,000 kilos, so it's 2,000 G, and that angle there, sine theta is 1/20. So what we can do is, if we subtract 2,000 G times 1/20, that's our sine of theta. And then we have to do the same here at the van, which would be almost the same, except this time the weight is 1,200. So we have to subtract 1,200 G times 1/20. So if we calculate that, that's our resultant forces. And remember, we use our Newton's law of motion, force equals mass times acceleration. So these should equal mass times acceleration. We'll come to that in a moment. Let's deal with these first. There's quite a lot here. So 2320 minus 800 minus 240, that's going to give me 1,280. So let's just write it in its number format for now. 1280. 2,000 times 1/20, that's 100. So it's going to be minus 100 G. And here, 1,200 divided by 20 is 60. So that'd be minus 60 G. And that also equals mass times acceleration. Now we can just tidy this thing up. 1280 minus 160 G equals mass times acceleration. Now the total mass is 3,200. That's the weight of the two vehicles. And acceleration, which is what we need to find. So now if we divide both sides by 3,200, we'll get our acceleration. So then acceleration equals 1280 minus 160 G over 3,200. So let's type that into our calculator. So gravity, we use 9.81 as our constant. So we've got 1280 minus 160 times 9.81, and then divide that by 3200, and we get minus 0.905. So A equals minus 0.0905. That's using a gravitational constant of 9.81. So therefore, with this negative, we see that the truck doesn't have enough power to pull uphill. So therefore, it's going downhill. So if I write there downhill, so that's our motion there. There's not enough power. Acceleration we've now got, so I can write that in there. So that equals minus 0.0905. Now we need to calculate tension. So let's calculate tension. Maybe let's just go at the van. So we can isolate from this point onwards. So what have we got here? So tension is going in the positive direction. We'll subtract 240. And then the van, we've got the weight of the van. So what's going on at the van? We've got this one here, which is 60g. So we've got to subtract 60g. And then that equals mass times acceleration, which is 1200 times minus 0.0905. So that again using force equals mass times acceleration. So if we move all of this over to this side, we can then calculate our resultant tension. So tension would equal 240 plus 60g, so 60g, and then this is a minus, so we'll need to subtract that from it. So minus 1200 times, all in a bracket here because it's got a minus and a minus. So minus 1200 times 0.0905. So that's utilising that minus into there. So let's plug that into our calculator and see what we get. So it's 1200 and then plus 240 and then plus 60 times 9.81. So then we get 720. So T equals 720 newtons. So calculate tension, 720 newtons. So then that will give us all of the answers that we need to answer our questions. Okay.